Welcome back to Learning Solidity. Now in today's tutorial we're going to be carrying on from our previous tutorial where we were looking at the web3j client to allow us to interact with the Ethereum network through Java. Now in today's tutorial I'm just going to expand on that a little bit. I'm going to try and break this up into small bite-sized chunks just so you can get a better understanding of how to use the web3j client. Now as you saw in our previous tutorial we were able just to extract the version of the Web3 client that the Ethereum network is running. Now obviously using Ganache it tells us that we're using the test RPC. So now to expand on this a little bit more, we're going to start using one of the wallets from the actual test RPC network. Now connecting to the Ethereum network through the test RPC opposed from connecting to the live network is a little bit different. You can configure them to work similarly, but it's a lot of messing around, especially on the setup of the Ganache side of things. Now if you want to use Ganache out of the box, it can be done. You just need a slightly different connection string than you would for using a real life wallet. So let's start by creating a very simple connection function. Now our connection function is basically just going to load our credentials so we can actually use them to, say for instance, send Ether over the network through the web3j client. Okay, so if I run the little bit of Java we had from the previous tutorial, we should still be able to connect to the Ethereum or the test RPC network and find out that we are still accessing the test RPC v2.1.0. Okay, so our connection is still working and I still have the Ganache client open. So what we need to do now is define our credentials. Now our credentials is obviously what defines our wallet, and usually that's a combination of a private key and a passphrase. So those in essence are all you need. Now there's a couple of ways that we can go about this. So if we were connecting to the live network, we'd need to specify, or we could specify, a wallet file. So by that I'll show you a very quick example. So let's create a method called private. It's not going to return anything, actually it's going to return credentials, and it's going to specify get credentials from wallet. So inside our get credentials from wallet, what we're going to do is first initialize our credentials, and we're going to load them from the wallet utility. Now let me just refer to my previous slide here just to verify that I am doing this the correct way. Okay, so to actually access the wallet utility we can simply specify wallet utils, and we have a range of mechanisms that we use to load credentials. We can use the two load credential methods, which is what we're going to do, but let's have a quick look at what else we can do. We can load credentials from BIP39, which is a password and a mnemonic. We can also generate a BIP for now. I'll skip past the generation methods because that's essentially a way of generating a wallet. I believe there is another mechanism, or is it only the three? Get default key from directory. No, I believe there is only the three methods. So what we're going to do is simply state load credentials. Now our load credentials needs two parameters. The first is our passphrase or password to our wallet, and the second is our wallet path. Now that's probably going to throw an exception, so we're going to chuck that into the signature of the method. And what else are we missing? Wallet.credentials, load credentials. Have I missed something there? Should be a path, wallet credentials, wallet utils.load credentials, incompatible types required credentials, and returns the I'm using the wrong import, that is why. I shouldn't have just imported the first thing I found. export class. That should get me the right one. Now I don't have to assign this to a variable. What I could simply do is return that, and obviously if we had these two defined, we would load the credentials from our basically our path specified, and obviously preload them with the passphrase. But what we're going to do is allow us to connect with Ganache. Now Ganache doesn't come natively with a wallet sort of JSON file. You can generate them, it is possible to do, but it just seems like a little bit of hassle when you don't really need to. So what we can do is we can generate credentials from the private key. So to do this, all you need to do is create a method again, call this credentials, and we're going to say get credentials from private key. Now all we're going to do is return if I remember correctly for this one, it is a credentials.create. Now credentials.create takes in 3 different methods. So you can pass in a key pair, 2 strings, which if I'm correct is the public key and the private key, or just the private key. So we're going to use this method at the bottom here, which is just for the private key. Yeah, so you got essentially the 3 methods here: the private key, and the public key, or the EC key pair. So we only want the latter for now, so let's just simply state our private key. Now you're probably asking the question, where do I get the private key from? So if we kick up Ganache, you'll notice there's a little key icon next to each of your wallets. If you click on the show keys, you get the private key. If you copy that, you can simply use that as a string as the private key for your wallet. And that is as simple as it is to actually get set the credentials for Ganache with the web3j client. Now what I'm going to do is I'm going to move this down to a separate function, private void print. I'm going to say print web3 version. Now I need to use the web3j, so I need to move that up there, and we'll pass that in as a parameter. Now again, we're not really going to use that function for now, so I'll just dump it up there. So we have our web3j, we have our credentials from our private key. You probably want to do something like specify this as a static final method. So you do something similar to private final static private key is equal to a string, and it also needs the data type of a string too. And that can be set right there. Okie dokie. So we should have the ability to access the web3j as well as our credentials. So the next thing that we're going to do with this is a very simple transaction. There's a couple of ways of doing this. I'm going to do it the way that I found it was a little bit easier for defining certain things. You can define a gas price and the gas limit only in certain implementations of what I'm going to show you, and because of this, what I'm going to do is create 2 static variables again. So private final static big integer. Now the reason we're using big integer is because we're referencing the gas limit and the gas price, which if you remember from a previous tutorial, these are quite big numbers. So what I'm going to do is actually take the gas price and the gas limit from the example I already had, or the ones that are currently set inside Ganache. Now I could obviously config this and set them myself inside chain in the configuration settings of Ganache, but I'm going to leave them as the defaults and just use them. So I'm going to create a big integer, and I say gas limit is equal to, let me just check, what was that? That was gas price, so gas limit equals a new big integer. Is that right? And actually no, and state value of a long. So we have private final static big integer gas price is equal to big integer dot value of gas price long. Okay. So now we have the gas limit and the gas price. We can use these for making our calls. So what we're going to do is simply transfer 1 Ethereum from our first wallet, which is going to be this one here, to our second wallet down here. All we're going to need for this is the address that we're going to be sending the Ethereum to. So create a private final static string recipient. Okie dokie. So with everything defined, all we need to do is now make the web3j calls, which are going to work in the following way. So first we need a transaction manager, and our transaction manager is simply going to be the raw transaction manager, which takes 3 parameters. So the first parameter is going to be the web3j. That should also be new as well. New. So web3j. The second parameter is our credentials. So we're going to say get. Actually, we need to instantiate this before that we can do anything with it. So what I'm going to do is actually move all this to public. Actually, private main its own constructor. And that is simply just going to call itself new. Okay, so now we should be able to access, get credentials from private key. And the third thing that we can pass to this is the chain ID. Now there might be a little bit of confusion to what the chain ID is. The chain ID defines what the Ethereum network is. For instance, if it's chain ID 1, it's Ethereum. If it's chain ID 61, it's Ethereum Classic. Now, there's been a lot of confusion around the chain ID and the network ID. They're completely separate things. For instance, you can have 10 different Ethereum networks running off ranges 1 to 10. They would all use chain ID 1 because they're all following the Ethereum sort of definitional convention. If you wanted 5 Ethereum networks and 5 Ethereum Classic networks, you could have networks running from IDs, obviously again 1 to 5 in both cases, but with the network ID of 1 for Ethereum and 61 for Ethereum Classic. Now I can simply state for this one it's -1. Actually I can't, because it is in fact a byte value, as you see there, but because we necessarily don't need this, we can just simply negate it. So we can still create our transaction manager without a chain ID. So if you were doing some programming for Ethereum Classic, that is where you'd need to specify 61 as a byte value, which you can just simply do by saying byte 61. And that's setting the chain to be the Ethereum Classic chain rather than the Ethereum chain. That's very important to set, otherwise your blocks or your transactions won't sign correctly. So just a side note for that. So the next thing that we need to do, now we have a transaction manager, is issue or create a transfer. So let's create a transfer, and for this transfer we're going to create a new transfer. I'm going to pass 2 parameters to it. We're going to pass the web3j, and then we're going to pass in the transaction manager. The next thing that we're going to do is actually do the transfer of the Ethereum from the first contract, from the first address to the second address. So we can do this by first creating a transaction receipt. Now, the reason I do a transaction receipt is so I can actually see that it's been created, it's been allocated to a block, and so forth and so forth. So let's say transaction receipt. Transaction receipt is going to be equal to the transfer dot, we're going to be sending funds. So our send fund method takes, well, it can take various parameters, but obviously now you see that we have access to be able to pass in a gas limit and a gas value as well. Now if you were doing this without the transaction manager, you can call this, I think, directly with the transfer dot send funds, but you are limited by not being able to set a gas limit or a gas price. Now, if you were going to do that, you wouldn't need a transaction manager or a transfer. You could simply just state transfer dot, then pass in your credential, your web3j, your credentials, and then all the denominations you actually need for this. But we're going to use the transaction manager and the transfer to do this, so we can actually define our gas price and our gas limit as well. So we're going to be first sending it to our recipient, which is going to be the first address. We're going to then state the amount that we're going to transfer. So in this case, it's going to be a big decimal 1. Then the next thing is going to be our unit price. So because we're sending 1, we're just going to send 1 ether. So we can do convert dot unit dot, and then we obviously have the various denominations of Ethereum. Now I'm just going to set this to ether, so we're sending 1 ether, and then we can simply state the gas price and the gas limit, and that is essentially everything we need. And then finally issue send. Now it's obviously going to throw an exception, so let's add that to the signature. That's probably going to need to be surrounded by the try catch, or I can, yes, chuck in a try catch and do nothing with it. So if I kick up this and I play the application, now we should see 1 ether go from this account down into this account. Did it play? I don't think it did. Let's try that again. Should do now. Okay, so it's built in, and we have transferred 1 ether from this account to 1 ether on this account. Now I have a transaction hash mismatch exception. Now I've come across this a few times, and it seems to be very hit and miss. As you saw, the transaction actually sent correctly, but what seems to be happening is when the transfer is when basically the signature is verified, I'll actually show you the point in the code where this is actually getting triggered. So basically, inside the web3j framework, it's signing the transaction that you're sending. And then it's also comparing that against the transaction that the Ethereum test RPC returned. One way I found to get this working is to go into Ganache and then just basically do a hard reset on everything. I don't know why that works, it just seems to work. But I don't know if it's an issue with the test RPC and it actually doing the transaction hashing correctly, or if it's a problem with the web3j and it's sorry, not hashing its signatures correctly, and or if it's a web3j issue. I just know there's an inconsistency somewhere. I haven't debugged this massively. I've just debugged the sort of the web3j side of things. Everything seems to look right. If you do experience this issue, the best thing I can suggest is just doing a complete reset of Ganache. And in fact, I think that is because I am running the wrong version of Ganache. If I just go into advanced, yes, I am using the wrong version of Ganache here, which I think actually this version that I am using here had a bug in it. So if I just kill that one off and boot up Ganache, there's a couple of different versions I have on my computer. Let me just try this one. Is that going to start Ganache for me? I can tell you, yeah, this is the correct version. So, yeah, that's definitely the right version. So let me just update the parameters that I had originally. So there's a private key is going to be the first one. So that should be different, which it is. Brilliant. Then the second address is different as well. And the gas price is correct. The gas limit is slightly different. And what I'm going to do at the end is just verify that everything's worked. Let's just print out the transaction hash. Transaction is equal to transaction receipt dot should be a transaction hash in here. So now if I run this again, this time obviously with the newer version of Ganache, it should transfer, and hopefully this time we've not had any errors. Okay, so everything's worked this time. So like I said, if you're having that error where it's a transaction mismatch, make sure you've got the most up-to-date version of Ganache like I have here, and everything seems to work. So I think there might have been a bug with the signing of transactions in that older version of Ganache, or the test RPC that I was using. But either way, that is simply a way that we can interact with not just the live RPC, we can interact with the test RPC in a very simple way using private keys. And that is where I'm going to wrap it up for today. In the next tutorial, I'm going to start looking at interacting with smart contracts through the web3j client. Now, I hope that you found this tutorial useful, and I'll catch you next time.